Hello students, today's discussion is based on magnetic field induction, magnetic field induction due to arc or current carrying arc, current carrying arc, circular arc, otherwise arc, anyone you can say this. So just one for the problem solving, how to solve the problems based on this. So first I am taking as there is a circular arc. This is the arc. It's a, let it be the current passing in this direction. Okay. So if any circular arc is there, how do you calculate the direction of magnetic field? Okay. So to find the direction of magnetic field, direction of magnetic field, direction of magnetic field. So I can use by using right hand curl fingers rule. Okay, curl fingers. So right hand curl fingers rule is just right hand. So this is these curl fingers are in the direction of current, and so this thumb indicates what? Direction of magnetic field. For example, if it is, so there is a circular arc, the current is passing in this way. Okay, it's what? I. So if it is, just if I place that circular curl fingers are in the direction of this, okay, thumb is into the plane, the magnetic field is into the plane. And next one is, so if you go for this in this direction, if the current is passing in this direction, so the magnetic field is the current passing in this way, so the thumb is out the plane like this. Okay, you know this one, into the plane means what? Minus k cap, and out the plane means what? K cap. Okay, x, y and z. Z is what? Perpendicular to the screen. Okay, so here this is the point for this one. If I want to find this one, it's a right hand curl fingers rule. So I am applying like this one, thumb is into the plane. Into the plane means what? For example, at this point I want to find it, and this is the line joining from here. Okay, it's what? Radius. This is the radius. It is into the plane means what? Cross. Okay, so now the angle between these two edges, which one is that? Inside this one, inside the arc, not outside. So this we have to take it as, this is theta. Okay, total angle is theta. So now we can go for this. B is equals to mu naught I by 4 pi r into theta. Theta must be in radian. So theta must be in radians. Okay, so this is the basic information. So by using this one, I am going to calculate, because if you know this form, okay, we can, because in every, so and JEE mains level and advanced level are for NEET students also. So this is what a wire is bent in the different shapes. Okay, semicircle and straight wire, like based on that. So for all those cases, this is the principle. Okay, so what is the formula? B is equals to mu naught I by 4 pi r. R is the radius. Okay, so just let me check on this one by one. So first one, for example, if I use it about, very first one is semicircle. Okay, semicircle. For semicircle is, so this is the semicircle. Now here is a point, its point O is the direction. So it is what? Into the plane, magnetic field is into the plane. So this is the line joining from these ends like this. This makes angle theta. Theta is equal to what? Pi. Okay, so what's your formula? B is equals to mu naught I by 4 pi r times of theta. Theta is what? It must be in radian. This is pi and it is into the plane or out the plane? Into the plane. Into the plane is what it say? Cross. Okay. So, now B is equals to mu naught I by 4 pi r. So, it's a pi. So, this is pi and pi cancel. B is equals to mu naught I by 4 r. Okay. So, it is into the plane. This is into the plane. If you want to write the sign convention, into the plane means what? Negative z axis. Out the plane means what? Positive z axis. So, minus k cap also we can write it. Okay. So, next one is the quadrant of a circle. Okay. Second. So, quadrant. So, for example, this is what? Some axis x and y. Okay. Like this again. This is the quadrant. Right. So, it's what? The angle between these two ends here. So, this makes an angle is what? Pi by 2 radian. Okay. So, now directly I am writing this one. B is equals to mu naught I by 4 pi r into what? Pi by 2. So, pi and pi cancel. B is equals to mu naught I by 8 r. It's a into the plane. Direction I am taking this one. This is what? Into the plane. So, this is magnetic field due to an arc. Okay. First, just I have given magnetic field due to arc. Next, I am going to talk about this. So, derivation will do later. So, just how to solve the problem and which is most important repeated application. So, this is what arc. Next, I am moving about magnetic field due to straight current carrying wire. Okay. So, that also I will give the formula. Next one. So, it's what? Magnetic field. Next one is what? Magnetic field. So, magnetic field due to straight current carrying. Okay. So, due to straight current carrying conductor or okay. So, due to straight current carrying conductor. Otherwise, finite wire. You can also say it's a finite wire. So, this is here finite wire means like for the conductor I am taking. So, first one is this. This is a straight current carrying conductor. It's a straight current carrying conductor. Okay. So, this is what the current is passing is I. So, it's a finite length. I said this one, just a finite length. Okay. So, just again I am not giving the proof. Proof we will discuss later. So, just what? From this is what? Here I want to find the field. So, earlier for the arc given means what? Right hand curling finger rule. So, this curling finger means what? Curling fingers are in the direction of current and thumb indicates what? Direct magnetic field. If it is clockwise means what? The field is like this one. Anti-clockwise means what? Into the plane. So, like different applications we did it. So, now this is a straight wire. For the straight wire current carrying like this one. How do you find the direction of magnetic field? So, obviously, we can use a right hand thumb rule. Okay. So, right hand thumb rule. So, right hand thumb rule. So, current carrying conductor is held by your right hand. So, this your fingers are going into the screen. That's I can say it's a cross. Fingers are going into the screen. It's a cross. At what distance? This is what perpendicular distance you can draw it. This distance is what? D. And next one is this angle. This makes an angle. It's a let it be. This is first one is theta 1. Next one is what? Theta 1 and theta 2. So, which is positive and which is negative. So, will this the type of discussion we do in derivation. Just so how to go for the problem solving. It's a straight wire. So, this is the current I and let it be its length is L. Okay. Length is L. Okay. Finite wire no. So, this is what length L. Like is the finite wire. So, if you are infinite wire also sometimes we consider the length because length elements are considered. Okay. So, magnetic field induction B is equals to mu naught I by 4 pi d. Not I by 4 pi d. D is the perpendicular distance. okay, times of sin theta 1 plus sin theta 2, okay, is the case. B is equals to mu naught I by d times of sin theta 1 plus sin theta 2. Okay, so this is the theta 1 and theta 2 are the theta 1 is the angle made by the first end. Let it be this end is what A and this one is the B. A is, so it made an angle, so with the perpendicular bisector, that is what D, that angle is what theta 1, and next one is what it say theta 2. Okay, so this is basic condition. And next one, sir, how do you go for the direction of magnetic field? So it's obviously right hand thumb rule. It's a cross, here into, here is the out. Okay, so this is the thing. And next one, so what should I find about this? For the problem solving, whenever straight wire is given, sometimes in the problem it's given as like a straight current carrying conductor. I have to imagine it's a infinite straight current carrying conductor. Okay, I'll show that type of questions also. So very first one I am talking about, this is the finite length. Okay, if I talk about this infinite length, okay, infinite length. So infinite length means what? Infinite straight current carrying conductor. So infinite length is, whenever infinite length is given, so infinite length means what? Just imagine that it's, for example, this is the angle, it will be like this, if it is here like this, if it is like this. Infinite means what? Like a perpendicular to this. So that means what? Here theta 1 is equals to 90 degrees and theta 2 is equal to 90 degrees. Okay, so then we can write about this one. B is equals to mu naught I by 4 pi d times of sin 90 plus sin 90 degrees. Okay, so sin 90 degrees, sin 90, 1 plus 1 is a 2, 2 to cancel. This B is equals to mu naught I by 4 pi d into 2. Okay, it's a cross. So this B is equals to mu naught I by d or 2 pi r. Perpendicular distance means 2 pi r. Also we can write it. So this is the magnetic field due to infinite straight wire. Sir, what is the infinite straight wire? This is a straight wire. It's like this. Okay, infinite. At what distance you want to find? At this distance. Let it be this distance is what? R. Current is passing is what? Up. Okay, then magnetic field B is equals to what do you say? B is equals to mu naught I by 2 pi r cross. B is equals to mu naught I by 2 pi r. So this is what? Infinite. So if I talk about the semi-infinite wire means what? I have to sit at this position where I want to find the field like this. Okay, so next one is that semi-infinite wire. This is, next one is the semi-infinite wire. Okay, so means semi-infinite current carrying wire is the case. So for the semi-infinite current carrying wire, so this is what? First one is the straight wire. Okay, it's a straight wire. Now if you find at this position, this is what? Current passing like this one. So is the infinite length. Is what? Infinite length. At what distance? It's a d distance or r distance, your wish, like this one. Okay, so this is what? Current is what? I. This is the I. Now at this position it's what? Into the plane. Chalo, now you say first one is that for above one means what? Theta 1 is equals to 90 degrees for infinite. For finite means this is the line joining from here to here with the perpendicular bisector. So not bisector, like a perpendicular distance. So that's what? Theta 2 is equals to 0 degrees. So then B is equals to, we can write it as B is equals to, what is our general form? Mu naught I by 4 pi d times of sin 90, okay, plus sin 0, okay, sin 0. And again I am saying that, so that the angles should be taken at this point. If the angles are taken at the edges means what? That proof cos function we use, but I am suggesting you can go through this angles are measured with respect to the point. Okay, so this is what B is equals to, it's a sin 90 is 1, sin 0 is 0, B is equals to, I can say mu naught I by 4 pi d 4 pi r, anyone. So it's what? Cross. It's a into the plane. These are the cases for this the magnetic field due to straight current carrying conductors. So by using this one, we have to find very standard questions, simple questions, okay, for a NEET level students, for a JEE mains level questions also. So what type of questions? The simple thing is that I am showing it. When a wire is bent in the form of a triangle, a wire is bent in the form of a square, a wire is bent in the form of n-sided polygon. Okay, so what is the magnetic field induction at its center? Okay, let us see one by one. I am showing this one. So first one is that very first case, a wire is bent, okay, it's bent in the form of a triangle. Okay, so its length is what? L. Let it be, this is what? Okay, its length is L. Current is passing like this. When current is passing like this one, the field is, this is the current I. The field is at this position. You can say now, what is that? It is into the plane or out the plane. So it's what like this. This is what into the plane. It's a cross. This is cross. Okay. So magnetic field induction into the plane. So now let us see on this. Very first one, how many sides we have? There are the 3 sides. Okay. 3 sides. 3 sides means what? B. This is what A, B, C, like anything. Otherwise, so from this is what 3 sides we have. 3 sides means what? I want to find the magnetic field induction at this position. Then how? This is like from here one finite wire, here another finite wire. Okay. So this total, this is the angle. So what must be this angle? You know, theta. Theta is what? Theta is equals to pi by n. Okay, is the case. Our total angle is what? 2 theta. So this total angle is equal to pi by n. This total angle. So now this is n is what? Number of sides. It's a number of sides. Number of sides the polygon. How many sides we have? 3 sides. 3 sides means what you say? Theta is equal to pi by 3. Pi by 3. Let me go for the cross check. So here is the total should be 360. This is 120. Next one is 120. Next one is 120. So 120 half means what? It's a so 60, and next one is the 60 degrees. Either this method or this method. Anyone. So okay. So however, you should get the idea on this one. Is okay. So now I want to know about magnetic field induction at its centroid. P is equals to at center or centroid. P at centroid, B naught is equals to, okay, 3 times of B side. Okay, magnetic field induction to each side. So this is equals to 3 times of, what is the formula for side? Means what? Mu naught I by 4 pi d into sin theta 1 plus sin theta 2. For understanding, I am writing this again and again. So once while you are writing, you will get idea. So directly you can do it. Okay. So this is mu naught I by 4 pi d. What is the d? This. Okay. This is what? Equilateral triangle. For the equilateral triangle means what? This length is what? L by root 3. This length is what? L by 2 root 3. So then d is equals to L by 2 root 3. So this is 3 times of, okay, mu naught I by 4 pi into d means what? L by, it's a 2 root 3. So into theta 1 is what? 60 degrees. Theta 2 also 60 degrees. Sin 60 is what? Root 3 by 2. Root 3 by 2 plus root 3 by 2. It's a root 3. Okay. This is root 3. Now we can write on this one. So mu naught I by 4 pi, don't disturb this one. You keep like this. Okay. This 2 root 3 will go up this one. Root 3 into root 3 is 3. Okay. 3. 3 3s are 9. 9 2s are 18. So this is magnetic field induction. B naught is equals to mu naught I by 4 pi d. Okay. 4 pi d. It's not d. It's a L. Okay. So this is 4 pi L, okay, 4 pi L into 18. 18 mu naught I by 4 pi L. Sir, how did you calculate this one? By using just what? Finite wire length is considered. For the finite wire length means what? B not B at the centroid is equal to 3 times of B side. Okay. So now you can guess that one for the square. I am taking about square. Okay. So this is what? For next second one is that for the square. Square is what? Just you try yourself. It's what? It is like bent in a force. Okay. Four sided one. Its length is, this is L and next one is L. Okay. So N is equals to what? 4. N is equal to 4. Current passing is in this direction. Okay. So this is the point. It's what? Into the plane. Now one side I am taking this one. It's a one side like this. So this is the perpendicular. It's what? Theta 1 and theta 2. So just to guess this one. So theta, calculation of theta is very important. So here this is what total 360 I wanted. 90, 90, 90. Okay. Otherwise, so I said you that this theta is equals to pi by n. N means what? It's a 4. So this is what? Pi by 4. Pi by 4 means what? Say 45 degrees. Okay. So now this is what? It's a 45 degrees. It's a 45. This one also 45 degrees. Okay. Length is, total length is L. From here to here length will become as what? It's a L by 2. Then D is equals to what? L by 2. D is equals to L by 2. Chalo. Now we can go through this one. First one, V at the center. V at center, V naught is equals to 4 times of V side. Okay. Side. So this is equals to 4 times of V. Side means what? Mu naught I by 4 pi D. D means what? L by 2. Directly I am writing this. Okay. It's a L by 2. And sin theta 1 plus sin theta 2 means what? 2 sin 45 degrees. Okay. So this is equals to sin 45 means 1 by root 2. 1 by root 2 means here 2 means it remains root 2. Okay. So 4 to the 8. So this I can write on this now 4 as this and into 2 mu naught I by 4 pi L times of, okay, into 2 by 2. Okay. So root 2, this become as 8 root 2. 8 root 2 mu naught I by 4 pi L, the answer. Okay. So this is what for the 3 sides I have taken. For the 4 sides I have taken. Okay. Now I am going to find about for n-sided polygon. Okay. N-sided polygon. How do you calculate magnetic field induction at its center? Okay. So that will be the next one. Next one I am taking about n-sided polygon. So n-sided polygon means it has like it has n number of sides. Okay. So this is the center, right? Current is passing, let it be like this. Okay. Depends on the question, how the question will be framing, that you have to observe it. Okay. So this is what current is passing like Sterling people. It's out. Out means what? Okay. So this is this is one side I am taking this like this, one side I am taking. Okay. So this is what perpendicular distance. This perpendicular distance. These are the angles. So what must be the angles? So how many sides you have? N number of sides. Sides. Okay. N sides. Theta is equals to what? Pi by n. Okay. So this must be pi by n. Say pi by n. It's again pi by n. Okay. So it's a 90 degrees. This is what? 90 degrees. Which one? Here is a 90 degrees. So now you say this distance is what? This is a side length. Okay. Side length. For example, it's a side length is, I want to know this length. This is what, for example, its length is what? L. This is L. So it will become as what? L by 2. And also L by 2. Okay. So magnetic field induction B is equals to mu naught I by Okay, 4 pi d times of sin theta 1 plus sin theta 2. Okay, sin theta 1 plus sin theta 2. So this is a basic formula again for recollecting. I am writing this. Now, so what is the total? B at center is equals to n times of B of each side, B of each side. So this is B at center, B naught is equal. Okay, so it's what? N times B of each side. Each side means what you say? It's a mu naught. Okay, this is what? Mu naught by 4 pi d. D I don't know. You have to calculate this one. Okay, 4 pi d times of sin pi by sin pi by n plus sin pi by n. Okay, sin pi by n. So this is B naught is equal. First of all, you can go for the calculation of D. How do you calculate D? So this I know, this also I know. What can I take? It is what? The right angle, hypotenuse, the adjacent. This one is the opposite. Okay. So sin pi by n, tan I can take it, na? Tan. Okay. So tan pi by n, this distance is what? D I am taking this. Okay. So what? D. Tan pi by n is equals to tan pi by e. Okay. Opposite by d. Okay. So d is equals to what do you say? L into 1 by tan pi by n, the relation. Okay. So now we can talk on this one. B naught is equals to n times mu naught I by 4 pi. D means what? That is L by 2. L by 1 by tan pi by n means what? Cot pi by n. Okay. But into 2 sin pi by n. According to options, you can convert this. 1 by cot pi by n will become as what? Tan pi by n. So B naught is equals to n mu naught I by 4 pi L into numerator. This is what? 2. 2 into 2 is a 4. Okay, it's a 4. Next one, tan. This is what? Tan pi by n into sin pi by n, the relation. Okay, like this. This is for n-sided. N-sided polygon we can calculate this. Okay, is the way. So just I have given that. How do you find the magnetic field of a straight current carrying wire and what is its direction? And so for the finite length, infinite length and semi-infinite length, next level problems I will show you. So this is a general discussion about the magnetic field induction to straight current carrying wires.